continue with problem 6.4. Find the sum of integers between root 7 and root 137. So let's draw a number line. The good thing is that these numbers are fairly small numbers. So let's draw two number lines, in fact. The top one is the number for the line for integers. So 1, then 2, 3, 4, and so forth. And we'll continue like that. And then we here come to, let's say, 9, 10, 11, 12, 13, and continue forward. So let's call this number line n, where n is moving from 1, 2, 3, and so forth. And this number line we will call n square number line. So it is moving every square of every square of these numbers. So 1 will result in 1 square, which is 1. The next one will be 2 square, which is 4. The next one is 3 square, or 9, 16, and so forth. And then we continue here, 81, which is 9 square, 100, then 121, which is 11 square, then 144, then 169, and so forth. So we have to locate root 7 and root 137. Now you see, if this is the number line, this number line is the square root of that. So you can call this, let's say another designation would be, let's say we call it p. Then I can call this a square root of p number line. So let's look at root 7. Where would it be located? 7 is located between 4 and 9, somewhere here. That's where 7 is located. So it means that 7 will be located, root 7 will be located somewhere here. Similarly, 137 is located between 121 and 144. So root of 137 is located between 11 and 12. So once we have found their location on this number line, we can easily see that the numbers that we have to sum up, which are lying between root 7 and root 137, are 3, 4, etc., 9, 10, and 11. So 3 through 11. So we'll call required sum equals 3 plus 4 plus 5 up to 11. Now summing these numbers would not be very difficult, but one way to do it, I'll teach you a new method. One method I have done earlier, I think you can go back to topic 1, you will see that. I think in first or second problem I think I have done it, where I have summed a series. How you would you do that? 3 and 11, you pair them, which becomes 14. Then you will pair 4 and just the number before, which is 10. And like that, 5 will be paired with the number before 10, which is 9, and so forth. So where will you end up? 6 is going to be with 8. So I don't have to actually write dots here, because after 5 will come 6, will be paired with 8, and then 7 will be left alone. 7 is in between. 7 doesn't have any number to pair with. So we can see this is 14, 14, 14, 14, and then 7. So 4 times 14 plus 7 equals 56 plus 7, 63. Now this is fairly easy because these numbers are quite small, so it's easy to just combine them and see how you're going to find the total sum. But another way to do it is, let's say I call this sum S, and I rewrite it just to make sure we are clear. Then I have another sum where I am going to add 1 and 2. So I will add 3 here on both sides, or S plus 3 equals 1 plus 2 plus 3 plus 4 and so forth up to 11. And the sum of numbers from 1 up to n is represented as n times n plus 1 divided by 2. So that will give us 11 times 11 plus 1, which is 12, divided by 2. And this means if I cancel the factor 2, I get 66. And remember, S plus 3 has now become 66. So let's rewrite that. Or S equals 63. And that is your answer, the same answer that you found by pairing up and adding. So I will derive this later in my algebra course or algebra topic, but I would like you to use it again and again. N times n plus 1 by 2, which is sum of 1 up to n. So I can even kind of write it here. 1 plus 2 plus 3 plus up to whatever is the value of n. So if you have a series from 1 through n number and you are wanting to find the sum of it, it will be n times n plus 1 divided by 2.